So do you see NS here? Right, as one of them. So is the NS number 18,500? It is, right? So can we just say that NS is 18,005? I would. Okay, we pull it right out of the table. Now, what about S1, SM? What are these two things? Now, stupidly, I have to tell you, I'm a little annoyed with the code because, look, there's kind of three main columns to this chart, this table. One is the occupancy. One is the construction type. You can see it up there. And then that leaves this column, right? And what do they call that column? See footnotes. Does that make any sense to you? Shouldn't you be telling us what the hell this column is? I think so. I would call that column something like sprinkler. I always say sprinkler situation, but that's not a formal enough, right? But it's this whole column is about the presence or non-presence of sprinklers in your building. Okay? And so we know NS probably stands for what? Regarding sprinklers. No sprinklers. Not sprinklered. Okay? What about S1 and SM? What do you think these stand for? Anybody have a hot guess on it?
Did we talk about this last
We haven't. This is brand spanking new. You're going to learn it for the first time in your life today.
Level 1, like basic.
You're on to the right idea.
Oh, it just depends on how many sprinklers are at each level.
You might think that, okay? You're making it a little more complicated than it needs to be. You said S1 might be sprinklers on level 1.
Yeah, like not really. I was thinking more like about so SM will be like more sprinklers, like more budget with the sprinklers, so more efficient.
So you think it has to do with how, like, the number of sprinklers?
Yes.
I think you were closer when we were talking about sprinklers just on level 1. Okay. What I'll tell you is this: it's not even that complicated. All right, because in order to say this, okay, in order for Sarahi to say that the building is sprinklered, you have to have 100% of your building sprinkled. Okay, there is no, we're only going to sprinkle. Well, there is, but in this situation, if your building is not completely 100% sprinklered, you can't say it's in this case, you can't say it's sprinklered. Okay, it's either 100% sprinklered or it's not. All right. So these numbers, what these numbers stand for, these rows stand for S1, SM. What this stands for is a sprinklered one-story building. This is a sprinklered multi-story building. Okay? So the only time we use, this is probably the one that we use, I don't know, maybe the least, right? This is, if you have a one-story building and it's sprinklered, we use this middle row. If we have an any-story building and it's not sprinklered, we use this. And if we have a multi-story building, from 2 to 1 billion stories, we use this row here. Okay? So, based on the idea that we are sprinklered and we're 4 stories, okay, which one of these 3 are we going to get our A sub T number from? Is it going to be, look, we work our way over, all right, so my question is our number going to be 74,000 or 55 and a half?
55 and a half.
I agree, 55 and a half. It's a multi-story building, it's sprinklered, so 55 and a half. All right, 55.5. So that's kind of, and no, notice this. The NS number we pulled out, we just said, hey, it's always, we said, no matter what the actual situation is, we need this NS number as a part of our equation. Regardless of the presence of sprinklers or not, it's just a part of the equation that we need that number. The A sub T number, right? This is, so we're kind of divorcing ourselves from reality here, or we're at least divorcing ourselves from this, okay? When we're trying to get NS. But with this A sub T number, all of these things come into play when we pick A sub T. We have to acknowledge all of this stuff. All right? So that is to say, NS is always just NS. Okay? But A sub T comes to play with all of these influences come to bear on that. So that is to say, if you have, listen to me say this carefully. If you have a non-sprinklered building, these two numbers are going to be the same. Right? Because if we said sprinklers no, for the A sub T, we would have to use that non-sprinkled number. Okay? But if you have a sprinkled building, these two numbers are always going to be different. Because the NS is what it is, and this A sub T, we would either be using, based on the number of floors, we'd either be using the S1 number or the SM number. Okay? So another way to look at that is this. Okay? Right? A sub T. I wrote over this, but A sub T, right? It's the tabular area factor for the building in question. The building in question with the characteristics that it has. The NS number, it's that same, it's from table 506062, but it's the NS number regardless of whether in reality the building has sprinklers or not. Okay, are y'all tracking on that?
Yep.
Okay, all right. So check this out now. How many? So I want to say a couple more things about this equation. You can see we've got two equations here, right? 50621, 50623. I think it's dumb to have these two equations, and here's why. Because look at this. What is the difference between these two equations? What's the only difference?
S2.
Please?
Yeah, S2.
Are you looking at this?
Yeah.
What is that? That's not a 2. What does it say?
Oh, is that A?
Yeah, it's an A.
Oh, it looks like 2.
Yeah, okay. You glasses,
Yeah.
contact lenses? Okay.
No, I just need them.
Okay. All right. You work that out with
Yeah.
whoever's buying you glasses, including yourself. It's S sub A, okay? It says S sub A, and S sub A is the number of stories above grade plane, right? So do you see so what they're saying is, if you have a 1-story building, you can use this formula, but what if I use this formula on a 1-story building? If my S sub A is just 1, do you see how it comes out to be the same? Right? Because whatever all this jazz is, if I multiply it by 1, it's not going to be any different, right? So, yeah, I mean, if you have a 1-story building, could you just omit that? I suppose you could. But why have 2 formulas when one formula would work the same? I don't know. Ask the code writers. Anyway, we are in our vignettes, we all have multi-story buildings, so we're going to focus on this 50623 equation as the one we're more interested in. All right, so what do we know so far? We know half these numbers. We know how to find, let's check them off. No, not that, hold on. We know how to find A sub T. We know how to find NS, because those are just table lookups, aren't they? Right? We get those right off of this table, don't we? All right? Now S sub A is the number. Don't worry about this bottom statement. I think this bottom statement is not super important right now. S sub A, we know S sub A to be the number of stories above the grade plane, not to exceed 3. Okay? So let's talk about this. So, we got a 1-story building, S sub A is 1. We got a 2-story building, S sub A is 2. We got a 3-story building, S sub A is 3. We got a 4-story building, S sub A is what? S sub A, the definition of S sub A is number of stories above grade plane not to exceed 3. So if I have a 4-story building, what am I going to plug in here for S sub A? What are some possible answers?
Wouldn't you do like 3 and then it's just more than that?
So you think it in a if I have a
Because on the table it says like the unlimited, so it doesn't give you like an exact answer for those ones. But if it's more than the 3, would it be unlimited or would it use this?
wouldn't be unlimited,
But
right?
would you use 3 instead of?
I would use 3. The highest this can be, what this is saying is the highest this can be is 3. Okay? When we go to calculate, okay, the highest this number can be is 3. So if I have a 4, 5, 6, 8, 10, 20, 50-story building, what I use here is 3. Okay? It goes 1 to 1, 2 to 2, 3 to 3, 4 to 3, 5 to 3, 6 to 3, 7 to 3, 8 to 3, right? So it maxes out at 3. If you have an 8-story building, what are you going to use? Here. 3. Got it? Okay. All right. So we know that. Now the only thing left is, we know this one. We get this one done. We have one term left, and that is I sub F. And I sub F is the area increase due to frontage. Okay. So, spoiler alert. I sub F, look here. I sub F has its own formula, right? So we always have to, when we do these allowable area calculations, the first thing that I typically do is I try to figure I sub F, because that's its own kind of problem. All right? You have this in your little 2-page packet. All right? I sub F has its own formula. We'll go over that in painful detail in a minute. But let's explain and understand what I sub F even is. All right? So we know that the building code gives us advantages when we do things in our building design that makes our building inherently safer, right? Higher level of higher level of construction, meaning more fire resistance, right? Adding sprinklers, okay? And those are largely things that we do to the building itself. But what if we, now think back to Vignette 2 and the first part of Vignette 2, what if we placed our building on the site in a way that, that would allow the fire department to have a good chance at fighting the fire? Meaning, we gotta have space for people to drive the fire trucks, close to our building. We have to have space for people to drag hoses around the building and stand back sufficiently far from the building which is on fire and squirt the water at the building, right? And so, essentially what we're saying is, if there is open space sufficient for firefighting people and firefighting equipment to be on that particular side of the building, the code is going to give us a bonus for that. The code recognizes that makes a safer building, and the code says because your building is safer, we're going to allow that building to be larger. Okay? So the question then is, what is a sufficient amount of open space, and where do we measure it from? All right? So the answer to the first question is pretty easy. If you have open space greater or equal to 20 feet perpendicular just like we did fire separation distance in chapter 6, was that perpendicular distance from the exterior wall to the property line. This kind of distance here, right? So for wall A, right, the perpendicular distance from the wall to the property line, that distance there, 18 feet, right? For wall B, see it down here, 50 feet, right? I got 50 feet of open space between the exterior wall and that property line. The code says that's good, right? It's greater than 20. Code says, good job. You can get all kinds of firefighting equipment and people on this side of the building, and therefore that part of the building is going to be inherently safer. We're going to give you an area bonus, maybe. Now, you appreciate, 20 feet is not a lot. What? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So about the middle of the table where Jostin is sitting out to the wall, that's about 20 feet, right? So if you have that, right, somebody can get in there, they could drive something in there maybe, or maybe get a person and a hose and whatever there. Now you can appreciate if that number, just take it to the extreme, if that number were 800 feet, right? No one's standing 600 feet back from a building trying to fight a fire, right? So the code says there are limits here. So the code says as long as you're 20 feet away, as long as you have 20 feet of open space, good job, we're going to give you a bonus. But the code then also says after 30 feet, we're still going to give you a bonus, but after 30 feet, we're going to kind of cap what that bonus is. So there's some magic here between 20 feet and 30 feet, and I'm gonna show you what that magic is here just in a minute. So first of all, just the notion of what this frontage increase is, or sometimes I call it frontage increase, sometimes I call it open space increase. All right, it's the idea that if we have open space, that gives the firefighters a chance to fight the fire properly. Instead of, what if there was a fire in this building here, right? Like, who's gonna go in here and try to fight the fire in that alley? Not happening, right? What's the point I wanted to make? Oh, but look out here. What's out here? What do we see past the end of this little alleyway? What's out here? It's a street, right? Now, let's just think back to chapter 6 for a minute and fire separation distances. All right. When we got to the street for table 602 and fire separation distances, and we said, yeah, you can go from the face of that building out to the street. But where did we say you had to measure to on the street? The middle, because the building on one side got half, right? And then the building on the other side got half the street. That has to do with fire leaping from one building to the other, right? And so we split that street half and half because each building has the advantage. With frontage increase, the code makes an assumption, they make a reasonable assumption that it's a very, very low likelihood that both buildings are going to across the street from one another, are going to independently catch on fire at the same time. So what they're saying is, we're assuming we're going to be fighting one fire at a time. And thus, you can use the whole street for your fire trucks and all that jazz. And so when they talk about the whole street then, they say, on the street side, when it comes to open space and get into that 20 feet and that 30 feet, when it comes to open space, you can go from the exterior wall all the way to the far side of the street. Because that's all the whole street is open space, right? Okay, so just keep in mind, chapter 6, table 602, fire separation distance, you go to the middle. When you're measuring for allowable area, I sub F, and frontage increase, you go to the far side of the street, you get the whole street, okay? They're both dealing with streets, but we're approaching it a little bit differently because of the reason why we're assessing that area, that space, all right? So, let's talk a little bit here. there's a formula, all right? Once again, we have some variables. All right, I'll give you a minute to catch up here. How we doing on time? Oh, we're doing all right. We have some variables, okay? We have I sub f is the thing we're trying to get to, because we know that I sub f is in this formula. This is the number we're really trying to get to, right? And we can't get to this number, the allowable area, the maximum area allowed by code. We can't get to that number until we have I sub f, because I sub f is a part of this equation, isn't it? All right. So I sub f, we got a few things here. There are three variables here. There's two of them that require explanation. There's one of them that's super easy. The easy one is P. Okay? P is the perimeter of the building. So in this case, right, you're going to do this problem in a minute. In this case, it's 130 plus another 100 makes 230, plus another 130 over here makes 360, plus another 100 here makes 460, right? So you can do the perimeter, right? You can figure the perimeter of the building. That's just like, fourth grade geometry. What's the perimeter? What's the length? What's the total length of the exterior wall? What's the perimeter length of that building? It's a length. Okay? So, the next thing. We have to figure out what I'm going to call big W and F. All right? I'm going to go one slide back, and we're going to talk about this. By the way, if you don't think, first and foremost, if you don't think at least 25% of your perimeter is going to have, of your building's perimeter is going to have that 20 to 30 feet, don't even bother doing it, because the code says if you don't have at least 25% of your perimeter with open space, you are not allowed to take this increase. All right? But like in a square, that's just one of the sides. Okay? But just know that if your building is pinned in, on all sides, you can't, except maybe like one little sliver, don't bother. Okay? But we have this thing called big W, and there's stupidly, right? Look, how many formulas do we have to have? We have this formula, because we're trying to get to an answer for this formula, but to get to this formula's answer, we have big W, which requires the use of this formula. It's a third formula. All right? I know. You're okay with it though, right? You're tracking, right? Okay. So let's talk about the first thing we have to do in all of this is we have to figure out big W. All right? So big W has, we have to assess what this is this little multiplication problem here this is an assessment of one wall. This is an assessment of a second wall. Then there's an assessment of a third wall and a fourth wall and a fifth wall, etc. Until you get all the walls assessed. Then we add all those up and we divide by this weird thing F. So let's talk about these pairs first. All right? I have an example down here which will help us. But before we do that, I want to talk about, so we're trying to get to big W, but understand, to get to big W, we have a bunch of little w's. All right? So the little w is actually, this is where this perpendicular distance comes in. Okay? So for example, now listen, we have no street frontage here, right? We have no streets, so we can't take advantage of any streets. All we have here is just the property line. In reality, there would probably be at least one street here somewhere that we could take advantage of. In this little example, no streets, so we just go to the property line. So for example, what is little w for wall A? It's the perpendicular distance between the wall and the property line. 18 feet. Okay? What's little w for wall C? Someone whose name is not Kate. 25 feet, right? Okay. Wall B, little w is 50 feet. Okay. Now, we have little w, but we also have L, right? And so remember, this is an expression of one wall, this is an expression of another wall, and then the third and fourth and fifth wall till we've assessed all the walls, all the chunks. L is an expression of the length of that particular wall. So let's just do one that we know we can do. Let's do, so essentially, another way to write this, okay, would be this. In this context, it would be L of wall A times little w of wall A plus the length of wall B times the little w of wall B, all right, times, plus the length of wall C times the little w of wall C, and on and on and on, okay? So for example, let's just do, we can do wall A, we can do for A and C in this example, okay? What's the length of wall A? Can you add those two numbers on the bottom there?
100.
That's 100, right? 60 plus 40. Okay, so the length of wall A is 100 times, now, before I go any further, there's a little chart I want to draw for you, and you should draw this right into your notes, okay? Because remember, I just erased it, but remember I said there's some magic about at the 20-foot mark and then at the 30-foot mark, okay? And we're talking about these numbers, these perpendicular distance numbers. Not the length of the wall, but the distance between the wall and the property line. So the chart looks like this. One side is the actual length, and the other side is the value of little w, okay? So, when the actual length is between 0 and 19 feet, the value of little w is 0, right? Because we said we had to be at least 20 feet to make it worth our while. That's what the code thinks, all right? I'm not going to say length, I'm going to say actual distance, because length is something else. Call it actual distance. Okay? 0 to 19. What about when we are 20 to 30? Okay? Remember I said 20 to 30 is kind of the sweet spot, in a sense, right? If your distance, if your little w, your perpendicular number is between 20 and 30, we use the actual value. Okay? So for example, if little w is 25 for wall C, we're going to use 25. It's between 20 and 30, isn't it? Okay? Now, if you are greater than 30, okay, 31. Maybe, would it be better if I did it this way? Greater or equal to 31? 31 and higher? Let's do it this way. 31 and up, right? We use 30. We cap it at 30. So if your number, remember I said if you have 600 feet, it's kind of useless, right? The code only gives you that bonus benefit up to 30 feet. And then after that it says you're getting diminishing returns. We're going to say no more benefit or bonus for you. Okay? So knowing this, okay, let's do these little pairs for chunk A and chunk C. All right? So WA, little WA is, what's the actual length? 18, right? So what do we use for WA? 0, because it's less than 20. right, by the chart, okay? 0. We're gonna skip B for now because I don't have all the information up there. We don't know how long it is for starters. What about wall C? Let me ask you this question though. We don't have the length, right? So we don't know what the length is, but what about WB for chunk B? What do we say there? What is the actual length for chunk B?
30, so the length is
Length is 50. So we, based on my chart,
30.
yeah, okay, right? This is what this is saying here. Frontage width is greater than 30. A maximum value of 30 shall be used. Okay. I would use 30 here. And then chunk C is 60 feet long. So the length would be 60 times what? What's the Sarah? What's the perpendicular length for wall C?
25.
25 feet. So what do we use for WC?
20.
It's between 20 and 30. So when it's between 20 and 30, what do we use?
So it's gonna be like actual value.
The actual value, which is
25.
25. You got it. Okay? You got it? All right. Now, all of this crap, we're going to add all this up, right? We're going to go for every chunk of our wall. We got to do that for. And then, plus dot, 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 right? The rest of these, A, B, C, D, E, and F, right? The last 3, if you keep going around. Then we have to divide by this thing called F. And F is actually, F shows up in the equation for W. Okay, it's right here. And it also shows up in the equation for I sub F. So this number F that we have to get to, it's the length of the building that qualifies for frontage. Okay? So this F, the F, understand that the P number well, heavens, here it is. Understand that the P number is a measurement of wall length, right? It's the perimeter, right? But also understand that the F number is also a measurement of wall length. But we don't count all the walls. We only count the walls that have sufficient frontage in front of them. All right? So for example, back in our example here, if we are trying to count up the length of the walls that contribute to F, when I count wall A, does wall A have sufficient frontage in front of it? In other words, is the frontage distance for wall A above 20? It's not, right? So if I'm going for F, right? So F equals, look, in this particular equation, and in this particular example, F equals, would I use the length of wall A? No. Why? Because this is under 20, isn't it? Right? Would I use the length of wall B? Does wall B have sufficient frontage in front of it? Justin says yes. So F, in this particular equation, now understand what I'm about to write here is just specific to this building, in this building site, right? So